I thought that one thing to concentrate on for this is what stories does evolution tell? And this is a creative group, and maybe not everybody always thinks about science as telling stories, but even if you think about atoms acting at this tiny level to produce friction, that's a story, right? If a scientist is going to explain that to somebody, they have to muster a story about it, right? So what kind of stories does evolution tell? A lot of the stories involve things like stones and bones and geography and geology, but I think there's a bit more depth to it as well. I'm just going to tell you a few stories about evolution or from evolution. This is a population of Homo erectus. These skulls were found in Dmanisi in the Republic of Georgia, and these date very reliably to over 1.7 million years ago. This is the earliest known site of Homo erectus, of any genus Homo, folks coming out of Africa. It's very interesting. So what kind of story can we have? Well, here's an individual living in that population, right? And to think of it concretely like that is something that paleoanthropologists need to do in order to understand things. But also here is paleo-artist Elizabeth Daines, who's French, who has reconstructed this skull. This turns out to be a teenager. This teenager, we don't know what he died from, but she reconstructed his face very painstakingly using forensic principles, and we get this, this vision of this ape-like human or human-like ape, or however you would want to think about it. But it's just very interesting to me, all of the different aspects, the different ways you can come at scientific knowledge to understand it. And one thing to think about is what kinds of thoughts flitted across the brain of a teenager of a species with half our brain size. Well, this could bring us to a different story, a different member of that same population, right? Not a youngster. This person was very aged, infirm, had a badly abscessed jaw. That's all missing bone there. This person lived for more than a year with no usable teeth, right? How did they survive? There were very rudimentary tools here. We're not talking about these beautifully shaped organization tools or Gravettian tools. There was no fire. They weren't cooking food. How did this person survive? The inference is that others were taking care of them, perhaps even chewing their food for them. So you often hear that the kind of story that evolution tells is that these older forms had a really tough lifestyle, nasty, brutish, and short, were their lives. Instead, when we look at this, what does evolution suggest? That the social group was primary, that people were closely knit, that they cared about each other, and that they had empathy. Again, even a species with half our brain capacity, not a whole lot more than a chimpanzee, you see these features coming out. That's our legacy. Here's another story. This is a skull. It's over 13 million years old. And holding it there is my friend Isaiah. He is now director, was in grad school with him. He's now director of science at the Turkana Basin Institute, which is Richard Leakey's group, which I'm also privileged to work with. He and his team were out in the field for 2 weeks in an area that is known not to have very many fossils in it, but when you find them, they're very nicely preserved. And even the guys that are these expert fossil finders at TBI didn't really want to go out with him there because they didn't think they were going to find anything. They go out there, they find nothing, it's almost 2 weeks. And then John Akuzi, who smokes, they're walking along, it's 100 and some degrees. He goes to light up a cigarette, they shoo him away, you're gonna kill us with all this smoke and everything. And he walks off and he starts walking around looking at the ground, which is a telltale sign that somebody looking for fossils has maybe found something, but doesn't yet want to put the energy into in picking it up because it's probably the 30,000th one that they thought might be something, and especially after 2 weeks. So he's walking there around with his cigarette, and the group sees him. They come running over like, John, did you find something? He's like, I think it might be the kneecap of an elephant. And they're like, wow, because they've been 2 weeks out there, they found nothing. The kneecap of an elephant. And they brush it off, and this face emerges. You can see that could look like the kneecap of an elephant or anything else. But once they brushed it off, they immediately knew they had this fantastic skull, right? And so they're still working that site and finding amazing things. And what they're finding in this site is that this ape died, and this represents the last common ancestor of all of the living great apes and humans. It's right at the root of that, and it was in the middle of one of these famous fossil gaps where you don't have anything, which is why he was trying so hard to find something. But this is a once-in-a-lifetime find. Anyway, this it's a baby ape. This baby ape died when a volcano erupted and buried the forest in ash. And maybe she ran into a tree to hide, who knows what happens, but the head at least was preserved. We don't have any skeleton parts other than that, but beautifully preserved. And of course, you know, a skull like this, you don't know if there's something preserved inside it, right? Some of these things have brain case, you know, molds of the brain inside, brain casts and stuff. Can't crack it open like a walnut, right? That would destroy it. And so being inclined to cross disciplines like paleoanthropology and physics, Isaiah had friends at the synchrotron in Grenoble in France, and they spent 10 days scanning this thing thanks to the European Union's support of science. It was complimentary, or pro bono, and all of this stuff is in there. This is the bony ear canal, right? And you can get a lot of information from this. You can tell, for example, possibly what group size was typical of this organism. And you can tell they weren't doing the advanced acrobatics that you see in gibbons. You can tell a lot of things. Teeth, of course, are what you want to see in paleo, you know, in any kind of paleontology. So we have these mint condition teeth because they hadn't erupted yet. It's an infant. And so it's perfect. And inside, at sub-micron level scanning, you can count the tree rings effectively, right? Because a layer of enamel is laid down every day. And so, unprecedented in all of the history of anthropology, we know exactly, to within 2 weeks, how old this baby was when she died. She was 16 months old. You've never had that kind of data before. And so this is part of what comes from working together across disciplines. But it's also just a great story. And so there are other things that aren't even displayed on this that we're able to find on this skull. So super interesting. We get from this skull and from sort of growing out from that age using parameters that are typical for primates, that this probably, she looked something like this, baby gibbon. A short face, which is not what people were expecting from the last common ancestor. You think of a chimp with this long face. So anyway, the poor thing died 13 million years ago on one day and is supplying all of science with unprecedented data. So it's a pretty cool story. Here's another story also involving a volcano. This is about 3 million years ago in Tanzania. A volcano erupted. It was not as violent an eruption as the one that buried Alessi. The one that buried Alessi, you've got whole tree trunks that are buried like 6 foot tall, right? Like over 100 tree trunks. Here you don't have that. You just have a surface of ash. And after a short time after it was laid down, it rained and that hardened it like clay. And you have footprints in this ash preserved. And here, 3 or 4 individuals walked upright 3 million years ago, leaving these footprints. And you have a large adult, somewhat smaller adult. You have a kid. And the kid's footprints disappear at a certain point. And when they started looking around for him, they were walking. The kid was walking in the footsteps of the adult, playing like kids do. So this is pretty cool. If you look down here, there are other kinds of footprints. There are footprints of other animals. So the hominin footprints were probably made by Lucy's species, right? And you see there's no brain expansion at this point. This is a brain the size of a chimp. And yet you see the kind of life that these guys had. They were fully bipedal, but the head was still very similar to our current ape relatives. And those other organisms that also walked on that surface and left their footprints are from more than a dozen species of all different sizes. You've got bird prints there, all of these different things. And so what story does that tell us about these apes? bipedal apes, that they were in harmony with nature, right? They were one of the animals out there in the savannah, that togetherness was one of their hallmarks. Peace and humor of the kid walking in the footprints. So here's another story, and this isn't one of these sort of more sciencey sounding stories. Shortly after that, so about 1 million years later, in geologic terms shortly after, somewhat shortly after, around 2 million years, you start to get this brain expansion that we saw in the Homo erectus one. And what you get is a problem, because if you're having brain expansion in a pelvis to pass that baby that is used to accommodating something that's 400 cc's and you're trying to stuff an 800 cc object through there, there's going to be, you know, some issues. So anyway, it's possible that this is when the shortened gestation of humans. Humans have very short gestation period compared to chimps and gorillas. We ought to gestate for a good 6 months more than the 9 to be on a par with others. This could be why, because if you let that baby go to term, there's no way you can enlarge the pelvis enough to do that. So this could be a time in which this is happening. People are going to need more help at this time if you're having a baby that early. The babies are going to be much more reliant for a longer time. There's a whole bunch of things going on there, and as I mentioned about the evolution of milk, human milk, the first part of human milk, the first part of colostrum, actually doesn't feed the baby that much. It feeds the bacteria in the gut, which are very carefully aligned to the needs of the infant and the long-term health of the people. So it's super interesting. Anyway, that may be a moment around 2 million years ago, 2.5 million years ago, when brains started to expand, that you got larger body size in females, because they used to be smaller than males, and now we're roughly the same size, a little bit smaller. And it could be that that is also an adaptation to passing that large head through the birth canal. So it's a different kind of story, but one that has a lot of resonances. So anyway, I mentioned that Homo erectus migrated out of Africa around 1.7, 1.8 million years ago, started migrating out. That site in Georgia is here, between the lakes there. And we hear a lot about Homo erectus, right? This is one of the iconic human ancestors. So they did that, and they stuck around for a very long time, until around 250,000 years ago, so well over 1.5 million years. I want to bump up in time to 26,000 years ago. So again, an eye blink. We're talking about our own species here. This is another cave. It's in France. It's called Chauvet Caves. Some of you may have heard about it. And at one point in time, 26 million years ago, a child ran into this cave. The child left footprints, accompanied by footprints of her dog. A child and a dog ran into this cave, and then they turned around and ran out. And then shortly thereafter, the front of the cave collapsed, and nobody saw this cave again until about 20 years ago, when it was discovered. What did that child and the dog see, and people 20 years ago, were things like this. It is a fantastic work of art, and it's, well, the paintings are older than 26 million, or 26,000 rather. The paintings are over 30,000 years old, but they're gorgeous, right? And you can see in this, you know, the few strokes that were used to evoke those animals. You can see we have a few of these wild horses left, how much they look like that, but also that they've caught the motion of these. And when the French researchers discovered the cave and first went in, they thought this was a little odd, but it might be depicting something like that. But then they went at night one time, and they had, or maybe their lamps gave out or something, that they had flashlights instead. And the movement of the flashlights made it look like the horse is bobbing its head. So these are actually animations as well as gorgeous art. You know, what do you make of that? What does that story tell us about ourselves? To me, I think it says that art is a fundamental human adaptation, right? It's something that comes with our species. You see it manifest again and again in our history. And it also, for my friends here, shows the human-canine bond goes way back, right? It's perhaps also part of our adaptation, a little more recently And just to demonstrate that, this is a dog skull from about 30,000 years ago from Siberia, so about the same time as these were made. And this dog skull was found in a human burial ground, and it had grave goods, just like a human grave would have. And there's a thing sticking out the front of his mouth, if you can see it there, that's a mammoth bone. The dog has been sent into the afterlife with food. So, to go back a little bit to the story of Homo erectus, Homo erectus came out of Africa 1.8 million years ago, a very long time ago, and stuck around till at least as short a time ago as 250,000 years in China, and then some of the descendants later still. And these descendants became what are known as Archaic Homo sapiens. They're basically very like Homo erectus, but with a much larger brain, right? So these folks overlap our modern brain size completely. In fact, in the case of Neanderthals, it was larger on average than our brain size by quite a fair amount. So you have all these things, and people have been trying for many years to make a story out of this. What does it mean? Does it mean that the people in these various places evolved in parallel, in situ, to become the modern races? We now know that, no, these guys are not our ancestors. They're our cousins. They're our cousins. Now, a few of them that were related that stayed in Africa, a few of them are our ancestors, but for the most part, all these guys you find, they're our cousins. So back in Africa, you've got a lot of these archaic Homo sapiens as well, who are our cousins, not our ancestors. There's just a few sites where you get what appear to be us, with the much more slender build of modern humans, right? Ethiopia, Tanzania, South Africa, a few of these things. And then you can combine that now with data from DNA, right? And it has built up a picture combining the morphological, the anatomical data, and the genetic data to give a picture like this. So here you're back where that teenager, his ancestors came out of Africa to Georgia, and you got a spread of Homo erectus all over Eurasia. You got various things that people disagree on whether they're, should be called different species or not. But to me, I'm going to lump them all as roughly Homo erectus. You've got descendant here, Neanderthals. There's an interesting thing called the Hobbit, if you've heard about that. We could always talk about it. At around 300,000 years ago, our species arose, right? And it's this little bottleneck here, right? All of these things went extinct subsequently. And here's us, right? And for the most part, our history is in Africa, right? That's not exactly to scale. So it's an important thing to know. We're all descended from a group of about 600 people, about 300,000 years ago. And so what does that tell us? Well, it says that about 300,000 years ago, we speciated off from our cousins. We split subsequently into the Khoisan, who subsequently split into northern and southern Khoisan quite a long time ago. Then the Central African foragers split off, so the Mbuti Pygmies, for example. Then West Africans and East Africans split. And then subsequently, maybe 60,000 years ago, you have this tiny branch going off that constitutes all of the other people in the world. Just this tiny, we're all, everybody else, most of the people in this room are non-Africans. We're East Africans, we're just a tiny offshoot. This is humanity. It's almost all still in Africa. There's a site in South Africa that corresponds to this time period. Maybe we've found something there that is like the origin of our species, who's to say? But it's in a challenging new environment that you don't find a lot of organisms in. So it's near the seashore, and there may be an advantage there to this new environment, to our slender build and large brain, for understanding the tides, the phases of the moon, the seasons. And the brain size doesn't change much, but behavior does. And that may indicate some brain reorganization related to memory. And somewhat later, then you start to see manifestations of art. So in Malawi, 130,000 years ago, you get advanced tools, you get art like in the caves, you get what might be early written symbols, at least symbols, not necessarily language or writing, but written carved symbols. And then it disappears for a while, and you get this popping up, this art, sort of irrepressibly popping up over the history of the human species. So what does it mean? We're all African. There are no biologically based human races. It's more cultural, which doesn't mean it's not real, but it's not biological. The tiny twig of our tree of life that ended up in Europe, Asia, Australia, and the Americas branched off from East Africa less than 60,000 years ago. Things like art, social cohesion, coexistence with other animals, animal species are fundamental to our adaptation. If a worldwide catastrophe wiped out everybody except one tiny population deep in Africa, 86% of all human variation will have been preserved, so don't get too upset about that. So the story human evolution increasingly reveals is how tightly knit our human family really is. And despite the misuse of science and attempts to divide us and apparent differences in a few outward traits, our common evolutionary history as a young species deeply unites us. So, thank you very much.